In this video, I'm going to talk about how Pandas handles categorical data natively. In one of the previous videos, I already touched upon how this works. There was the video on numerical methods and operations in Pandas. There was an example where I simulated 10 million observations from standard normal distribution and split it into bins based on their values. So in that case, I was actually working with categorical data in Pandas, but we're going more into depth with this in this video. Okay, so we may first ask, are string columns attractive to work with? So the reason why I write object here is that when we have a Pandas series with strings, Pandas calls it calls the data type object and not strings. But are these attractive to work with? No, at least sometimes categorical data is better, and that's in particular the case when we have a large sets of or long series in Pandas of strings that have contain many characters. Then if we convert these observations to categories based on their string content, it requires less storage and it allows us to make faster computations. In addition, there is no real ordered structure on strings, but when we work with categorical data in Pandas, it's actually possible to order different values, different categories. That's not the case if you're just working with raw strings. And then working with categories, it also allows us to make bar plot, violin plots, etc. According to the category order. So we can make say for instance, a plot by category type. Okay, so these are some reasons why it may sometimes be a good idea to convert a string column in a data frame to a categorical column instead. So in order to show you how this works, I'm going to simulate data. So first, I'm creating a list of different types of education categories. So I have a bachelor in political science, I have secondary school, and then I have 2 instances of high school. Then based on this education list, I'm going to create a string series, which basically I'm going to do that with a Pandas series constructor, and this will basically just contain this list repeated many times. Okay. And then I'm going to create education categories. So we notice that in this string series, there will only be 3 education categories that will be called secondary school, high school, and bachelor in political science. Okay. So first we can work with categorical data. We can convert this series to a series of categorical data in a non-ordered way, and that's what we're going to see here. So here I'm creating a new Pandas series from my string series, but then I'm specifying that I want the data to be categorical, and I do that by writing as type. That's what we do when we convert one data type to another, and then I specify category. And then when I print just the first 5 element in this category series, I'm now given that the data type is called category. So if we were just working with strings, it would be called object, right? As we saw before. And then it also gives me the 3 categories that it observes in my that Pandas observes in my series. Okay. Okay. And now I'm going to show you how you can work with categorical data in an ordered way. So in the previous example, you saw that I simply just created a categorical series, Pandas series, by taking my string series and then just writing as type category. Now I'm going to do something differently. So I'm going to write PD categorical, and then I'm taking my string series, and then I'm specifying that the categories are these educats. And then I'm specifying also that educats, the elements in the educats, were already ordered. So I'm specifying that there is an order in these categories, and that order is given by the sequential order in which each of these elements show up in this list. Okay, So then I'm creating a new categorical series, so I call that categorical series 2 by using the pandas series constructor. And then I'm specifying that the values in this series should be what I generated with cats in this cats object. And then I'm just specifying also that the indices should come from my string series. And then I get the following output. So you can see that this, when I print the first 5 observations, it looks very similar to what I had before here. So it's basically just the same, right? But what's different here is that now these 3 categories are ordered. So it tells me that secondary school is less than high school, which is less than a bachelor in political science. So that was not the case here. There was no order down here. And that's basically the main difference between these 2 approaches. It allows me to specify an order. And that order is given by the sequential order of these different categories in this list. Okay. Okay, so it's natural to think of also continuous measures in categories. So even though we have a continuous or numeric variable, we may group in our heads, we may group values into different bins of small or large or something else, right? So we may ask, can we convert our numerical data to bins in a smart way in pandas? Yes, and there are 2 methods that are useful for these purposes, and one of them you have already seen before. That's the cut method. So the cut method allows you to divide data by bins that you have specified yourself. So that was what we did in the previous example in the video on numerical methods and operations, where we took the 10 million observations that were drawn from a standard normal distribution, and then we put these observations into different bins based on the categories, where the bins were specified in a NumPy array. We can also use QCut, which automatically divides the data by user specified quantiles. So we can, for instance, put observations into bins defined by, for instance, the median. So we can create two bins. So a bin for observations for values below the median, and a bin for values above the median. But we can also use different quantiles. We can specify that ourselves with QCut. So consider the following example here. So here I'm creating a new series, categorical series 3, and then I'm using this QCut method from pandas. So first I'm creating a pandas series now with a million randomly drawn observations from a standard normal distribution, and then I'm specifying that I want to create 3 different bins. So I want to create one bin for values between the minimum value and the quantile associated with 0.025, and then I want to create a bin for observations showing up in between these 2 quantiles, and then I want to create a bin associated with observations of values that show up in the top of the distribution here. And then what I do here is that I just display the different categories that I get out of this. Okay, so this is my minimum value, and this is what's associated with the quantile of 0.025 in my data set of a million observations drawn from a standard normal distribution. So this is around the value that we would expect, right, if we know the standard normal distribution. And then a bin for all the observations between quantile 0.025 and 0.975, and then the top values here as well, a bin for the top values. So I've created 3 different bins here, right? And I can also check which bins these the different observations in my simulated data set show up. So we can see here in this case that all my first 5 observations, they all belong to the second bin. So that's that's this interval, right? So that's also what we would expect. This is by far the largest interval here. Okay. So we can also convert our string or categorical variables into dummy variables. So if you have taken an introductory course in applied statistics or econometrics, you will know that for many many empirical analysis, it can be quite useful to work with dummy variables. So what we do when we convert a string or categorical variable into a dummy variable is that we create a variable for all categories in our data, and we create a new column for each category, and the values that these columns can take are either 0 or 1. So as you also know from these introductory courses in statistics or econometrics, you will know that often you will want to leave one reference category out. Okay. So how do we do this? So fortunately, there is a quite a simple method in Pandas, which is simply called get dummies. So how do you use this method? So you consider the previous example from the categorical series data, where we had 3 different categories that were defined by using the QCOT method. And then I want to create a new data frame that splits these categories into dummy variables. And I simply just do that by writing pd get dummies, and then I specify my categorical series 3 here, and then I print the first 5 observations from this new data frame. So you can see that I have now created a dummy variable for each of these 3 intervals that are defined with the QCOT method. And here I can also see that as we just saw before, that the first 5 observations they belong to the middle category, which is again by far the largest category of the 3. But here you can see that's how you create dummy variables for categorical variables, which can be useful for many types of analysis.